Hello! We're going to be looking at solving a system of linear equations. And in this video we'll be looking at a specific example, but the way you solve these are going to be essentially the same. We're going to be using our calculator to help us do Gauss-Jordan elimination, so I'll be incorporating the calculator and some commands as well. We're going to be looking at solving this system of equation. It's x plus 2y plus z is equal to 8, and minus 3x minus 6y plus 9z is equal to 3. The first thing we want to do is set up a matrix for this system. So a matrix is going to be looking at how many rows and how many columns we have. In this equation, like the rest of our examples, the number of rows will be determined by the number of equations. We have 2 rows here. And the number of columns will depend on the number of variables we have in constants. We look at this example and we have 1, 2, 3 rows of variables, but we also have this augmented row of constants. So we're going to be looking at putting in a 2x4 matrix in our calculator. That's the dimensions of the matrix. So I've set this matrix up here. You can see the first part is what I call the coefficient matrix. Because essentially that is going to consist of the coefficients of our system. These are sometimes referred to as the constants. And when we set up this matrix, really our variables are stripped away, but those will come back into play. So here's my calculator. I'm going to enter this in. I go to Matrix, I arrow over to Edit, and I know that this is going to be a 2x4 with the augmentation that I was telling you about. I type in 1, 2, 1, 8 going across. My second row would be minus 3, minus 6, 9, 3 going across. I'm going to quit out of there. I'm going to use a command called RREF. This RREF in matrix does reduced row echelon form. It does Gauss-Jordan elimination. I arrow over to Math and up. I find RREF. I do matrix again and type in A. So the RREF, or reduced row echelon form of A, is given there. Notice I have decimals, so if I'd like to turn those into fractions, I do math frac. And there's my fractions. So my reduced row echelon form, I can just say, well, I've done RREF on the calculator to show your teacher that you've gone through this Gauss-Jordan elimination. I have 1, 2, 0, augmented with 23 fourths, and I have 0, 0, 1, augmented with 9 fourths. Okay, I'm going to leave my calculator aside now. The next thing I want to do is turn this over into a system of equations. So this is going to become 1x plus 2y plus 0z is equal to 23 fourths. 0x plus 0y plus 1z is equal to 9 fourths. Notice that I wouldn't really have to put those zeros in, but I do so just in this case for teaching purposes. Okay, you might notice that in reduced row echelon form I have 2 1s here. These are called pivots. So these variables are going to be my pivots. What this means is x is going to be a pivot and z is going to be a pivot. That means y is going to be what we call free. So pivots and free variables are important in our study because pivots you will be able to solve for those in terms of the free variable, and free variables are free to do what they want to. So I'm going to go ahead and solve for these pivots. To do so, I'm going to subtract this 2y over in the first place. So I'll get x is equal to 23/4 minus 2y. My next variable would be y, and notice that it's free, so if I have a free variable, I just say, well, it's free to do what it wants to do. So I'm going to say y is equal to y, and then I'm going to solve for this pivot z, but it's already there. I have z is equal to 9/4. This would be a very nice representation of our answer. And of course, this is true where y is any real number. Sometimes we want to write this in what we call a parametric form, a vector form. So we can write this in terms of a vector. We can say x, y, z vector is equal to, if I factor out that y, I would have -2, 1, and 0. Those are the coefficients in front of y. -2, 1, and there's 0 y's here. And then I'd be left with these constants, and that will be another vector. I'll have plus a vector of 23/4, 0, and 9/4. So this would be our answer in a vector form, a parametric form, where again y is any real number. What you can see when we do have free variables, we're going to have infinitely many solutions. If I didn't have a free variable there, then we would just have a unique solution. And sometimes we don't have any solutions, but those are our three cases. Well, I hope this has helped. Most of the examples are exactly the same. Thank you.